Today we're going to see how you can calculate hydraulic characteristics of a geothermal system in 5 minutes. You can go through and specify your min-max water temperatures, your flow rate per ton, a diversity factor if appropriate. Select your antifreeze. In this case, we'll pick methanol at a 15-degree freeze point, our default heat pumps and heat pump series, which will help you populate the zone tab. Here we can add a zone. We could modify the tag and the description. And we enter a heat load as well as a cooling load. And as you tab through, you're confirming the program will select a 4-ton Sycamore automatically, enter the flow rate. You pick the type of pipe and the program will calculate the proper diameter at 1.5 inch, 40 feet long. We got 8 elbows. We don't have a two-way valve, so we didn't put a CV in. Here's an option where you can enter a note or a comment specific to a heat pump, and you can actually dictate it. And you may have to edit it because it doesn't necessarily know what a de-superheater is. So you spend a little time cleaning it up to the level you want. But you can dictate it or you can type it. So it's a nice feature that remains a part of that particular heat pump. So once we've got one zone defined, we have another option to be able to duplicate that zone. And here we're going to duplicate it 4 times because our system has 5 heat pumps in it. So now we've got 5 heat pumps, and we can go through and modify each one. All the parameters are completely adjustable. So here we're modifying the heat loads for each of these heat pumps. So the program will automatically select the heat pump that meets the most demanding load, either heating or cooling. In this particular case, we're also going to change that Sycamore to an OptiHeat. And you'll see the OptiHeat is flagged at 6.66 tons because we want it to be at a higher flow rate. The last heat pump is an Aston water to water. Might be serving a garage radiant system or something. The program will automatically populate the GPM based on the heat pump and the GPM per ton that was identified on the projects tab. So you can select the pipe material, the diameter, and once you're all done with your zones, you go to the loop field tab. And in this case, we've got 5 vertical bores. We're going to pick 1.5 inch, and they're 500 feet deep. So we got 5 vertical bores at 500 feet. We want a reverse return header. The spacing is going to be 20 feet instead of the default of 15. The length is the runout pipe. And for our 50 GPM, the program automatically picked 4 inch as being appropriate. So you review all your data, and if we wanted to change that 4 inch, we slip back into manual mode, and we can change that 3 inch as indicated there. So now you review the reverse return details, and when you find they're acceptable, one click, and you'll be able to create a drawing, which is also exportable as a DXF, which you can then put in your CAD drawings. So as we zoom in on the far right, it illustrates the flow and total pressure drop and breaks it out with the loop pressure drop at 16.7 and so on. So that was less than 5 minutes. And I asked, can you do similar work in less than 5 minutes?